ALU is just piecing things together.
All right, back to, yeah, exactly. Back to Scrumdo. Again, yeah, there's a lot of work I'm assigning today, but that's how this course just goes down. So let's see, one thing I forgot to assign earlier was create the ALU. This is to actually create the ALU module. Now let's see, we got equality, adding, and here we do and instead.
It should all be 64-bit.
And yes, we all need to make it 64-bit. Someone forgot to update these cards. And let me check. That looks good. That looks good. All right. This one's not wow, excuse me. It's not too bad because you're really just pasting together your AND module, your plus module. You do have to write a quick, well, you actually have an equality module as well. Yep. So you're really just pasting them all together into an ALU. That's really all you're doing.
Yep. Cool.
All right, but back to assembly. Our final two assembly. Oh, I wonder where the other ones went. Loops and floating point. These two are going to be, I'm going to give you a C code and I'm going to tell you to spit out the assembly for it. If you try and use a compiler to spit out the assembly and paste that, it's going to be incredibly obvious to me. Trust me, it'll be really, really obvious to me that that's what you did. I have seen compilers spit out the result for this. Don't do it. It is so obvious, it's embarrassing. It really is. Anyways, here's the code I want you to translate into assembly, namely NASM assembly. Notice that we're getting a float from the user. We're going to store it as in, and then we're going to have a for loop that's kind of based on a float, so you'll have to think about how to do that. That might get a little weird for y'all. Start at 1, go up to n, float plus equals 1.0. The result we're adding, we're doing this calculation each time, and then we print off the result afterwards. What's nice about this is you have the C code. You can copy and paste that into a C file, compile and run, and then see if the output of that matches the output of your assembly file. Isn't that nice of me?
So what did you mean by using compiler to spit out the output?
So you can tell GCC to just give you the assembly as opposed to the binary.
Sounds like something nobody does.
Don't do that. Don't do that. You can tell GCC to do that. Don't. It'll be obvious to me that you didn't actually do this by hand. All right. Any other questions on this one? Because we did loops, we just did floating point, we did multiplication, we did division. Great. And then the last one is called recursion. We're just going to do a simple recursion 1. You get an integer from the user, and then you're going to print the return value of this function, which is really just summing from 1 to n of whatever n is. That's all it does.
Is that going to probably just be like...
If you implement this with a loop, obviously you're wrong.
It's not going to be doing a bunch of go-tos on the function, the sub, until you get what you want.
Well, the sub is going to have some go-tos in it because you have an if statement up top.
Yeah.
But it's going to call itself.
That's
So you got to think about the stack.
So you're going to like go to yourself, but then...
Who's doing that? Oh, that's awesome. How do you do that? For those of you at home, it looks like the projector's having a conniption or something, whatever that word is.
Telekinesis.
It's really hilarious to me.
So
but not
you're
y'all.
saying like something else isn't going to go to it. It's going to be like, here's my sub that does the thing. It's going to keep telling you to go to itself, but you have to make sure you don't.
Yeah,
blow it
don't mess up don't blow it up. Make sure you terminate. Any questions, comments, screams? We're getting good on those screams. All right,
One day I'm gonna have full on screen.
A whole lot of practice, but man, just want a full day of
Do like this.
knowledge.
Wow.
Okay. Yeah, that's a lot of cards.
That's a lot of cards.
Let me look at this.
That's a lot. It's not dry.
I do not see myself ever assigning the number of cards again.
Lay down. Try not to cry. Cry a lot.
All right, guys. It is a lot of work. I know. This is the hardest part of this course. You just got to get through it. Because what's happening, if you think about it, is we're tying everything together. We're tying how x86 assembly works, and hopefully you can see how translating an assembly-like language that I've presented with Little Computer 64 can be implemented in Verilog, and we've talked about in Verilog how we can translate that into circuitry and actually do the computations. Yes?
What do we get assigned next week?
So you just have less time to do it?
No. Wait, what?
Well, if I signed it next week, it'd still be due on the 24th.
How much are we getting assigned next
Oh, how much are we getting assigned next week? That's a good question. How many more weeks are left in this gate? 2? 3? Not including, no, the break is a break. The break does not exist. 2 full weeks, then there's no more cards in gate 2. Yeah, 2 weeks. 2 weeks left. Not putting any more in gate 2.
You were to sign those cards after this.
No, this is it. The end. But guys, again, this is the part where you have to be able to put it all together. After this, we're tacking things on to show you how we improve performance, how what's the security fallout of our design, the security fallout of all our performance enhancements of this basic design that we have come up with. This basic design basically gets us to the late 70s, by the way. And we're going to go from the late 70s to early 90s for the rest of this course.
Oh, don't forget to do something with assembly. Remake something in assembly. I forgot.
Thank
what
you.
it was.
Yes, I will need to update the assembly file for you.
That.
Fix the thing.
Fix the thing with the stuff.
The thingy.
Yes.
Do the thing.
All right. Do the thing with the stuff.
Presentations on Tuesday, right?
Presentations on Tuesday. Please help your fellow classmates out and be as nice as you can with your presentations. Especially if you can talk about how I talked about what instructions use it and how it would be implemented in your processor. So definitely get to that.
How do you want us to send it? So I guess you're gonna put it on the computer. Like, how do you want like a link or something?
Well, if you send me a link, upload it on YouTube's easiest. If you do it that way, or if you have PowerPoint, put it. If you have a PowerPoint, put it in GitHub.
Okay. But like when we go into class, do you like send a link, or is it gonna be a card or something? That's what I meant.
Oh no, I'll be grading you. Don't worry about that part.
Okay.
Excuse me, I'll get to. Oh wait, is there no card for this? Is that what you're saying?
I don't think there is.
Oh, I need to make a card. All right, I will make a card for this.
Now, do you want us to? No, it's just a file or.
Yeah, just if you want to, if it's a presentation, commit it to GitHub. If it's a video, put it on YouTube. Send me a link.
So we're doing groups.
What?
Do you want us all to do it?
Lovely. Yeah, you can do groups. Oh, everyone stands up.
We're doing no, so we're doing groups. Do we all need to send you? Or just like these people?
Just one. Yeah, I just need one. Yeah, come on. Just one. All right. Now, any other questions? All right, guys. Well, that's all for today. Have a great weekend. Team? Team? Oh, man. Oh, no.
If you get done telling Derek that we only needed one person to present the...
Wait, you only need to send me one link. You don't need to... Okay, I only need one presentation file from the group.
Okay.
So, how many people are in your group?
3.
3. So all 3 of y'all are going to present, and only one of y'all needs to send me the slides. I don't need 3 copies of the slides. That's all I was saying. That's all he was telling me.
Right.
That's it.
But if we're to make like a YouTube presentation,
Then you
all
just
3
need
of us
one
need to be... All 3 group members need to be in that presentation.
Yeah. Oh, is Whitney here? Whitney is not here. Okay.